Yeah, YouTube back. We're gonna burn some of this midnight oil. So I'm probably gonna do about 5 questions. I'm totally wiped out. Let's see how I can last my own stamina. I'm a little bit slap happy. My voice is stripped, uh, but let's see how far we can get on this. Even if it's just 2 questions or something, it's kind of worth it. Please like and subscribe. Um, this way we can have a mutual exchange. We'll be benefiting each other. The channel is helpful for people, and it seems like the right symbiotic thing to do here, right? So, all right. Let me just check that we're live. Where's my phone? Hopefully everybody's all right. You should all be asleep at this point, and this is mainly for test takers who are going to be taking it after that. Phone. Hopefully everybody's all right. All right, there we go. All right, let's jump into this and keep going till we all drop. All right, so I believe the last question I did was a few pages back. Oh, it's right here, I guess. All right, it says 97. All right. A bag contains 40 tiles that are either, I just set up my normal thing. They're not telling us, but I would normally put like 5 red, 6 green, whatever. So I'm just going to put the things down. There's red, there's green, and there's blue. And they were telling us the total is 40. Okay, so we're up to here. A tile is selected at random. The color is recorded and the tile is put back in the bag. So basically the bag always contains the 40 upon any selection, and it's random. So we're hopefully getting the statistical equivalent, the theoretical equivalent, then this, so this actual selection and recording and putting it back is our experiment's happening. So the process is carried out 120 times, and 18 of these times the red tile is selected. So that means 18 out of 40 times is the probability, the experimental probability of picking a red. Okay? So it says based on the information, meaning the experimental tests, the experimental probability, what is the most likely number of red tiles in the bag? So we don't know exactly, and this computation could be wrong. Sorry, I wrote the number here wrong. I read it was 18 out of 40. That's not true. It's 18 out of the 120 experiments. Okay. What we're going to do, though, to figure this out is that this is basically going to give us the experimental percent, right? If we divide 120 into 18, we're going to figure out the percent. So what we want to know is that percent out of 40. So out of 40 means times 40. All right? We have 40 tiles, and we're going to multiply them by the experimental probability of pulling a red. So that's what we're trying to figure out there. Okay? All right, I see a question. I'll answer it right after this question. Uh, what I can do is take the 40 is the same as 40 over 1. I can divide 40 into 40 one time. I can divide 40 into this 3 times. So I'm trying to avoid doing the multiplication. And then I see this 3 goes into 3 once and 3 goes into 18 6. And that's the answer. That multiplication is equal to 6. All right, because you could have done 18 times 40 and then divided that by 120. But the canceling out works. Just be careful canceling out because that can be an error-prone process. All right, and then the answer just turns out to be A. All right, and that makes sense. That if we just do estimation, if about 18 out of 120 were the experimental ones, then out of 100, right, then there's probably about 15. All right, which is about a sixth, if we would even simplify this even further. And a sixth of 40 is about 6 dot something. All right, so that pretty much rules out the D, the C, and the B. So this little quickie here, that can be our sanity check. All right, so that's not too bad a deal. So let's just take a sidebar here. Somebody writes, I have a question about exponents. For example, x, y, x divided by a y. How am I supposed to solve this? I'm not seeing an exponent there, so can you repost that maybe to qualify what you mean? What is the exponent? Do you mean x to the y or something like that? Or because if I take it for what I believe I'm seeing, let me get a little white space here. It looks like you wrote xy times x divided by y. So in this case, because the numerator means we can throw the parentheses away, x times y times x over y. We can throw this y out, and the answer would just be x squared. All right, okay, so you're changing that. Okay, so let's see. So you have x to the y divided by, no wait, times x over y. All right, so this is going to be x to the y plus 1 over y. First of all, you're not going to get this on the SHSAT. So I should probably really just spin off this into its own uh, video. This will not be on the SHSAT, and if it is, it'll be on the SHSAT 9. So when I cover the 9 stuff, just keep out a heads up for that, because I don't want to spend time on this streams doing questions that may not necessarily be there. These are good questions. They're normally questions dealing with uh, math team kind of questions. Um, so I'll hold off on doing this one and do it on another stream. This way we can focus on strictly on the SHSAT 8 kind of questions. All right. But it's a good question, and they're fun to play with those kind of questions. I'm not trying to dish a question, but this stream was focusing on the SHSAT Handbook Review. So, but it's a great question. What you can do is email it to me as well, GregsTutoringNYC@gmail.com. Yeah, you can email me that, and could probably send you a solution in the next day or two. All right. So we have a table. Last year's total attendance. The left-hand side has the attendees. The right-hand side has numbers. We have the total. Luckily, they added that up to us. Children, adult, and seniors, the respective numbers. If 100 individuals attend the museum next week, what is the best estimate based on last year's attendance? So this is last year's totals, okay, of the number of children who will be in that group, okay. So let's see, children out of the total is going to be 1750. out of 5,000. And if we so to me the easiest way is to get rid of this, so we get 175 over 500. Okay, and then basically what I'm going to do is multiply the numerator by 2 and multiply the denominator by 2. And I'm doing that because I'm going to get 350, is that, over 1,000. And I'm going to throw away the zeros again, and then I basically get 35%. Okay, so that becomes kind of easy math uh, to me. And then that's what they're asking. What is the best estimate out of 100 individuals? So it turns out that not only does this become 35%, but it means 35 out of 100. So it just kind of works out, and we get G for that. And that's all they're asking. We're trying to use the numbers to our advantage. We could have made this 10,000 and doubled every number as well over here, but we didn't really know where they were going on that. Okay, so that means 98 should be G. Let me just check here. Don't want to be giving you guys the wrong answers. 98 is G, yes. Okay. 98 we just did in the other stream, or 99 rather. So we're good with 99. We're going to try 100. So 100 is moving along from the probability, the one that we just did. So let's see. A bag contains 15 marbles, 11 blue and 4 red. For red is going to give us 15 total, which they told us. So we're only confirming. Sarah picks one marble randomly, returns it to the bag, and then randomly picks one marble again. So we have again it's being returned. What is the probability that she picks a red marble both times? So the first time, there's 4 red out of 15 marbles. Okay, she takes it, she puts it back. So the second time, there's still 4 red out of 15. So what's the probability that she picks a red and that she picks a red? So both times it's and, so we're going to use multiplication. So everybody can do 4 times 4 is 16, but you guys are supposed to know that 15 times 15 is 225. So you're not wasting time on the exam doing 15 times 15 kind of computations. So I have a products to know.pdf that links in through my website at the SHSAT facts that you guys should be able to get access to. Anyway, you should be memorizing not only your multiplication table up to 20 by 20, but that includes all your perfect squares, especially the teen ones. A lot of you guys don't know that, and you can be more accurate and save time on the exam by knowing those things. Okay? Yeah, you guys are right. Okay, so that's 100. Let me just check that I am doing the right thing because I'm running at the brink of exhaustion here. So 100 is E, yes. And I might just do about 1 or 2 more because I'm just slap happy at this point. Okay, this throws a lot of students off. It is kind of elusive, so let's just give it a shot. Let's look at the illustration first in and of itself. We have the left-hand column, report 1, 2, 3, 4. There's no title for this, so we don't even know what we're looking at. There's 4 subjects: geography, English, science, and math. And then it's talking top choices. The geography references 1, 2, 3, 4, 5 countries. Okay, New Zealand is not 2; it's 1. It's 1. So Kenya, Thailand, Chile, Greece, and New Zealand. So there's 5 countries here. The English references 3 authors. The science looks like it's referencing 3 things, but from what I could see, it's only referencing 1, and the math references pi and regular polyhedrons. So it's referencing 2 things. So we don't know what they're going for this. We didn't even know we have to write the 5, 3, 1, 2 along the sides of it. So Anita is assigned to report on one topic in each of the 4 subjects shown in the table above. How many different sets of 4 reports are possible according to the choices given to her? So all we have to do at this point is multiply them out. So we're going to get 5 times 3 times 2 times 1. Okay, so we get 15, 30, and that's just the answer. That's all the combinations that are possible. Okay, it didn't say unique versus whatever, so that's just the end of it. Yeah, I'm good. I'm good. Just trying to give back. I like giving back to you guys. So maybe we'll make the last one the last one. Let's see how hard these are. Let me just double check that 101 was 30. Yeah, it's C. 102, a deck of playing cards contains 13 hearts. All right. So most likely this is going to be a ratio. Let's see where it's going. So 13 hearts out of 52 cards. Maybe we don't need to do that ratio, but I'm just putting it down anyway. Sarah has 12 cards from the deck in her hand, 3 of which are hearts. So Sarah basically removed 12, if you will. So 3 hearts out of Sarah's 12 cards. So I'm just going to put Sarah there. That's her total. Okay, so we're up to here. The other cards remain in the deck. Okay, what is the probability that a card drawn at random from the remainder of the deck will be a heart? So first of all, if there's 52 cards and we take the 12 out that Sarah has, there's 40 cards left, right? And if there was originally 13 hearts and Sarah took 3 of them, then there's 10 hearts left. I'm going to put TC here for total cards. All right. So that means the probability at that point is the 10 out of the 40. We can drop the zeros and we get 1 out of 4. So that's all they're asking there. Yep, you guys got it. Very good. Let me see here. I'm looking at the screen blurry too. So on top of that, I'm not seeing the best I can see. Let's do this one. Let me shrink this down slightly. So we have a table of 4 different flavors of candy and the probability of picking those apparently out of stuff. Okay, so there's really nothing else going on in that illustration. It says the table shows the probability of randomly picking each flavor of candy from a bowl. Yeehaw. Okay, which flavor is most likely to be picked randomly? So we're looking for the highest number here, which would just be the butterscotch, right? When something's fully probable of being picked is 1. When it's not going to be picked at all, it's 0. So we're trying to look for the highest number out of that group of things there, okay? And if you will, because these are decimals and they're based on percents, this is 57 out of 100, okay? This is 9.5 out of 100. This is 12.5 out of 100, right? So this is 21%. So obviously the highest percent is the 57. So that's what we want to look at. So 103 should be A. Let's just double check that. Maybe I should just keep going till I make a mistake. Okay. $104. You know what? I should just probably call it a day while I'm ahead here. And I can do the others at some other time. Again, guys, please like and subscribe. Does anybody have any remaining questions about anything we covered so far? Because I'm definitely running on empty. I haven't eaten anything yet either. So I haven't eaten anything since like 10 o'clock this morning. So any remaining questions? You guys go. You guys are the legends. You guys give me incentive and so on. All right. I'll continue some of this tomorrow. Actually, I think I'm doing it tomorrow is a live stream, just to celebrate you guys taking the exam. Let's see if that works. Um, I have to clear time to be able to do that. So, all right, guys, get a good sleep. Peace and love, y'all.